Between June 1950 and the final German surrender, Soviet factories produced over 36,000 Il-2 ground attack aircraft, more than any single piloted military aircraft type in aviation history, while simultaneously manufacturing thousands of Yak-9 fighters, 10,000 La-series interceptors, and dozens of experimental variants that would reshape global aviation forever. This staggering industrial achievement occurred while the Soviet Union fought for survival against the Wehrmacht, with entire production facilities relocated hundreds of miles from advancing German forces and workers who had never seen aircraft before the war, learning to build complex fighters in weeks. From Alexander Yakovlev's altitude-focused design philosophy to the all-metal construction revolution that emerged from desperate wartime innovation, Soviet aircraft development transformed a technologically inferior air force into a superpower that would soon challenge American jets over Korean skies. This is how every major Soviet aircraft type evolved from wood and fabric desperation to jet-age dominance, and why those production numbers tell only part of the story. The Yakovlev Revolution emerged from systematic development programs that would establish the foundation for an entire family of Soviet fighters. Alexander Yakovlev had already proven himself as an aircraft designer, and his evolving design philosophy represented something different. Where other Soviet fighters prioritized raw speed or heavy armament, Yakovlev's approach centered on robust performance at altitude. This wasn't just about flying higher than the enemy. It was about maintaining combat effectiveness where most aircraft struggled to operate. The Yak-7 development validated Yakovlev's approach, demonstrating stable handling characteristics and reliable engine performance at altitudes that left other fighters gasping for air. Soviet test pilots reported that the aircraft felt solid, predictable, and forgiving, qualities that would prove invaluable when inexperienced pilots found themselves in combat against veteran Luftwaffe aces. But Yakovlev wasn't satisfied with existing performance levels. Even as prototypes underwent testing, his design team was already working on improvements. Better armament, refined aerodynamics, enhanced engine cooling. The Yak-7 had proven the concept, but the war demanded something more capable. Something that could not just survive combat, but dominate it. By late 1942, that something was taking shape on drawing boards across the Soviet Union. The Yak-9 was coming. Operation Uranus began on November 19, 1942, with Soviet forces launching their massive counteroffensive around Stalingrad. But the ground assault was only part of the plan. High above the frozen steppe, a new aircraft was about to make its combat debut. The Yak-9 had evolved directly from the Yak-7 design, incorporating 2 years of wartime lessons and engineering refinements. When the first Yak-9s entered combat in late 1942, Soviet pilots discovered they had a weapon that could compete effectively with German fighters. The aircraft handled beautifully at altitude, exactly as Yakovlev had intended. Its armament proved effective against both German fighters and ground targets. Most importantly, it could be produced in massive numbers without compromising quality. Soviet factory workers were already building Yak-9s faster than pilots could be trained to fly them. The aircraft's design allowed for relatively simple manufacturing techniques, using materials that remained available even as the war economy strained Soviet resources. By spring 1943, the obsolete Founder-16 fighter was being phased out of frontline service, replaced by growing numbers of Yak-1s and Yak-7s. The transition marked a turning point in Soviet air power. No longer would Soviet pilots face the Luftwaffe with inferior equipment. The Yak-9 had leveled the playing field, but the war's greatest test was still approaching. Kursk represented the largest tank battle in human history, but the aerial combat above those burning fields would prove equally decisive. In July 1943, Soviet aircraft underwent their baptism of fire over the contested ground around the Kursk salient. Specialized Yak-9 variants carried heavier armament than their predecessors, designed primarily for air superiority, but capable of engaging armored ground targets when necessary. Soviet engineers had learned from months of combat experience that versatility mattered more than specialization. A fighter that could only fight other fighters was useful. A fighter that could also destroy tanks, trucks, and artillery positions was invaluable. Combat trials at Kursk validated this approach. Pilots reported successful engagements against Messerschmitt fighters and Focke-Wulf attack aircraft. They also documented effective attacks on German armor and supply convoys. The aircraft performed exactly as designed, proving that Soviet engineering had mastered the art of multi-role combat aircraft. Following the Kursk battles, improved variants entered production and distribution to frontline units. Over the following months, Soviet factories would produce substantial numbers of these versatile fighters. Each one represented a step toward air superiority that seemed impossible just 2 years earlier. Soviet aircraft development during the war years produced numerous experimental designs, some successful, others abandoned after brief testing. The Il-1 fighter prototype fell into the latter category, but its story revealed the ambitious scope of Soviet aviation research. Engineers at the Ilyushin Design Bureau had attempted to develop a dedicated fighter using their design expertise. The concept seemed logical. Ilyushin's experience with robust construction would give pilots a significant advantage in air-to-air combat. Their proven engineering approach could handle the stresses of aggressive maneuvering. The existing production infrastructure meant rapid deployment to operational units, but flight testing revealed fatal flaws in the design. The aircraft's performance characteristics reduced its speed to levels that made it vulnerable to modern German fighters. Test pilots discovered that the prototype could barely intercept older Luftwaffe bombers, let alone engage contemporary fighters like the Messerschmitt 109 or Focke-Wulf 190. The project was quietly abandoned, its lessons absorbed into ongoing development programs. Not every Soviet aircraft experiment succeeded, but each failure provided valuable data for future designs. The Il-2 would remain a ground attack specialist, leaving air-to-air combat to aircraft better suited for that role. 1944 brought new challenges and new opportunities for Soviet aircraft development. The Red Army was advancing on multiple fronts, but the Luftwaffe remained a formidable opponent. German pilots might be outnumbered, but they were flying increasingly sophisticated aircraft with improved performance characteristics. Soviet designers responded with their most advanced wartime fighter variants. The Yak-3 represented the pinnacle of wartime Yakovlev development, incorporating more powerful engines that delivered significantly enhanced performance compared to previous variants. The aircraft also carried improved armament configurations that increased their combat effectiveness. These improvements came at a cost. The more powerful engines required additional cooling systems and structural reinforcements. The enhanced armament affected the aircraft's balance and handling characteristics. Soviet engineers spent months refining the designs, conducting extensive flight testing to ensure that performance improvements didn't compromise the aircraft's fundamental reliability. Advanced variants entered service in mid-1944, just as Soviet forces were preparing for their final push toward Berlin. Pilots who flew both earlier and later variants reported noticeable improvements in climb rate, maximum speed, and firepower effectiveness. The aircraft had evolved from capable fighters into formidable weapon systems. The end of the Second World War didn't end Soviet aircraft development. If anything, it accelerated the pace of innovation as designers incorporated wartime lessons into peacetime projects. Post-war jet variants represented a fundamental shift in Soviet fighter construction. Where previous variants had used mixed construction techniques, combining metal frameworks with fabric covering, newer jet aircraft featured all-metal airframes. This change wasn't just cosmetic. All-metal construction provided better protection against battle damage, improved structural integrity at high speeds, and simplified maintenance procedures. Soviet engineers had learned during the war that aircraft needed to survive not just enemy fire, but the harsh conditions of field operations. Fabric-covered control surfaces deteriorated rapidly in extreme weather. Mixed construction techniques created maintenance headaches for ground crews working without proper facilities. Advanced variants addressed these problems, while maintaining the flight characteristics that made the Yak family successful. Production continued through the late 1940s, with each aircraft representing the most advanced version of proven designs. But even as these aircraft rolled off production lines, international tensions were rising. The Cold War was beginning, and Soviet aircraft would soon face new challenges. The Korean conflict began in June 1950, but Soviet aircraft technology would soon be tested against Western opponents in this new theater. During this period, the Soviet Union provided military aid to Allied forces, including advanced jet fighters that represented the first test of Soviet aviation technology against Western opponents since the Second World War. Allied pilots, many trained in the Soviet Union, would fly these MiG-15s against American aircraft over Korean skies. Soviet-supplied aircraft proved capable in early engagements, successfully intercepting American bombers, though facing challenges against escort fighters. But these aircraft also revealed the limitations of early jet technology when faced with advanced jet-powered opponents. American jet fighters possessed certain advantages that Soviet jets struggled to match. Soviet observers carefully documented these encounters, gathering intelligence that would influence the next generation of aircraft. Development. The Korean conflict demonstrated that the era of propeller fighters was ending, but it also validated many Soviet design principles. Rugged construction, reliable engines, and effective armament remained important even in the jet age. The Korean service of Soviet aircraft provided valuable lessons for future aircraft programs. The Lavochkin aircraft family played a crucial role in Soviet aviation development, with their story well documented in aviation history. What records reveal are aircraft that complemented the Yakovlev fighters while pursuing different design philosophies. Where Yakovlev emphasized altitude performance and reliability, Lavochkin designers focused on speed and agility. The La-series fighters earned reputations as formidable interceptors, capable of engaging the fastest German aircraft on equal terms. Soviet pilots who flew both Yak and La fighters often reported distinct differences in handling characteristics and combat capabilities. Comprehensive records of La-series development show approximately 10,000 La-5 and La-7 fighters were produced during the war. Soviet authorities initially treated much information about these aircraft as state secrets, but documentation became available following Cold War declassification. This information represents one of the valuable aspects of studying Soviet aviation. The aircraft existed, they fought, and they contributed to Soviet victory, and their full story is now largely known. What remains clear is that the La-series fighters formed an essential component of Soviet air power during the war's crucial years. Soviet pilot training programs relied heavily on specialized aircraft designed specifically for instruction and skill development. The Yak-18 served as the primary training aircraft for thousands of Soviet pilots throughout the war and into the post-war period. This aircraft bridged the gap between basic flight instruction and advanced combat training, providing student pilots with experience in high-performance aircraft handling without the complexity of frontline fighters. The Yak-18's design emphasized safety and forgiveness, allowing inexperienced pilots to make mistakes without fatal consequences. Its handling characteristics deliberately mimicked those of operational fighters, ensuring that pilots who graduated to combat aircraft would find familiar control responses and flight behavior. Soviet training programs produced pilots at an unprecedented rate during the war years, and the Yak-18 played an essential role in that achievement. Without adequate training, aircraft, even the most advanced fighters, would be useless. The Yak-18 ensured that Soviet factories' massive aircraft production was matched by equally massive pilot training programs. Every pilot who flew a Yak-9 in combat had likely learned basic fighter techniques in a Yak-18. The training aircraft might not have received the recognition of their combat counterparts, but they were equally essential to Soviet victory. The scale of Soviet aircraft production during the Second World War defied every previous manufacturing achievement in aviation history. The Il-2 alone exceeded 36,000 aircraft, but that number represented just one type among dozens of different models produced simultaneously. Soviet factories built Yak-9 fighters by the thousands, each aircraft requiring hundreds of individual components manufactured to precise specifications. The Yak fighter family became among the most mass-produced Soviet aircraft of the entire war, with production lines operating around the clock to meet frontline demands. This manufacturing miracle occurred while the Soviet Union was fighting for its survival, with many factories relocated hundreds of miles from advancing German forces. Workers who had never seen an aircraft before the war learned to build complex fighters in a matter of weeks. Quality control systems ensured that rapidly produced aircraft met combat requirements without sacrificing safety or performance. The production achievement represented more than industrial capacity. It demonstrated the Soviet system's ability to mobilize resources and coordinate massive undertakings under extreme pressure. Every aircraft that rolled off those production lines carried the hopes and determination of a nation refusing to surrender. The numbers spoke for themselves, but behind each statistic was a story of human dedication and engineering excellence. Soviet aircraft development during wartime operated under unique pressures that forced rapid innovation and continuous improvement. The Il-2 underwent numerous incremental upgrades throughout its production run, with changes implemented based on combat reports from frontline units. These modifications included various improvements that enhanced the aircraft's ground attack capabilities and flight characteristics based on operational experience. Soviet engineers didn't have the luxury of extensive peacetime testing programs. Changes had to be implemented quickly, tested under combat conditions, and refined based on immediate feedback from operational units. This process created an unprecedented cycle of innovation, where aircraft evolved continuously rather than through discrete generational improvements. Pilots flying Il-2s in 1943 were operating significantly different aircraft than those delivered in 1941, even though they carried the same basic designation. The evolution continued throughout combat operations, with each improvement representing lessons learned from previous engagements. This approach to aircraft development would influence Soviet design philosophy for decades after the war ended. The concept of continuous improvement under operational conditions became a hallmark of Soviet aviation programs, distinguishing them from Western development practices that emphasized longer design cycles and more extensive pre-production testing. The design philosophy that unified Soviet aircraft development during this period emphasized practical combat effectiveness over technological sophistication. The Yak family of fighters embodied this approach through their focus on robust performance at altitude, but the principle extended across all Soviet aircraft types. Engineers prioritized reliability over complexity, choosing proven technologies over experimental innovations when aircraft were needed immediately for combat operations. This philosophy didn't represent technological conservatism or lack of innovation. Instead, it reflected a clear understanding of wartime priorities and operational requirements. Soviet designers understood that the most advanced aircraft in the world was useless if it couldn't be produced quickly, maintained easily, or operated by pilots with limited training time. The emphasis on battlefield effectiveness created aircraft that might not have impressed peacetime observers with cutting-edge features, but consistently performed their missions under combat conditions. Soviet pilots reported high confidence levels in their aircraft's reliability, a crucial factor in combat effectiveness that couldn't be measured by performance specifications alone. This design philosophy would continue to influence Soviet aviation development long after the war ended, creating a distinctive approach to aircraft design that prioritized operational utility over technological demonstration. The transformation of Soviet aviation from desperate wartime production to post-war technological leadership represented one of the most remarkable achievements in aerospace history. In 1941, Soviet aircraft were generally inferior to their German counterparts, forcing pilots to rely on courage and tactics rather than superior equipment. By 1945, Soviet aircraft matched or exceeded German performance in most categories, and production numbers overwhelmed any remaining technical advantages the Luftwaffe possessed. The transition from wood and fabric construction to all-metal airframes symbolized this broader transformation. Early war Soviet aircraft used whatever materials were available, often resulting in mixed construction techniques that complicated production and maintenance. By war's end, Soviet factories were producing sophisticated all-metal aircraft that incorporated advanced manufacturing techniques and design principles learned from years of combat experience. The post-war period saw this evolution continue, with Soviet aircraft designers applying wartime lessons to increasingly ambitious projects. The same engineers who had struggled to match German fighter performance were soon developing aircraft that would challenge American and British designs for global supremacy. The foundation laid during the desperate years of the Great Patriotic War supported decades of subsequent innovation and achievement. The legacy of Soviet aircraft development during the Second World War extended far beyond the immediate military victory it helped achieve. The production techniques pioneered in Soviet factories influenced global aircraft manufacturing for decades afterward. The emphasis on rapid production without compromising quality became a model studied by aviation industries worldwide. The design philosophy that prioritized robust performance and battlefield effectiveness over technological complexity shaped aircraft development programs in numerous countries. Soviet innovations in all-metal construction, engine cooling, and armament integration found their way into aircraft designs around the world. The massive scale of Soviet production demonstrated that aircraft could be manufactured like other industrial products, using assembly line techniques and standardized components to achieve unprecedented output levels. This approach revolutionized thinking about aircraft manufacturing, moving it from a craft-based industry to true mass production. The Il-2's record as the most produced military aircraft in aviation history stood as testament to what could be achieved when industrial capacity, engineering excellence, and national determination combined. But perhaps most importantly, Soviet aircraft development during this period proved that innovation thrived under pressure, that necessity truly was the mother of invention, and that the gap between technological leadership and technological application could be closed through focused effort and unwavering commitment. The aircraft that emerged from Soviet factories during those crucial years didn't just win a war. They changed forever how the world thought about aviation, production, and the relationship between technology and national power.